Alrighty. Thank you everyone for coming. This is obviously, as the slide says, HVAC and D for dehumidification approaches for cultivation facilities. Please forgive me. My name's Troy Rippe. I'm a little sweaty. I landed about 25 minutes ago. Gotta love flying after COVID here and all the fun that brings. I was about 3 hours late, so made it, but excuse me for being a little out of sorts possibly here. With that said, we'd like to get the session started. A couple minutes behind. Do some introductions to start. My name's Troy Rippe. I'm the Vice President of Development for Surna Cultivation Technologies. My background's completely in commercial construction, almost 20 years now. 12 years of that in standard or what you'd call non-cultivation commercial construction, and then the last 5 years in various roles at Surna. Primarily all mechanical engineering, that's my degree, and focused on different technologies and ways to apply them in this specific vertical market. I think we got a pretty interesting panel for you here. I'd like to introduce some of my cohorts. Really the goal here when we put this panel together was to kind of try to capture some of the different stakeholders and people that have interest in the process of putting together your HVACD system for commercial cultivation. I'm hoping a lot of you are aware, but in case you aren't, this is probably, as we see it, we've done over 200 of these. This is going to be one of your 3 biggest CapEx spends in most cases, if you're building a grow, depending on if you buy your building or not. And it's going to have significant impact on your OpEx. So obviously, operational costs are impacted by the systems, these HVAC systems, and not to mention your grower and the plants that they can develop is all too critically developed, are contingent upon the temperature and humidity set points we can hit in these facilities. So with that, like I was saying, we do have 3 different people here with me on the panel, all representing a little different vantage point in the process. To my left is Brian York, and kind of representing the owner-operator angle, and I'll let Brian introduce himself from there.
Thank you, Troy. Thanks, everybody, for coming out. Like Troy said, I think we've got a pretty well presentation for you guys. Go over the different approaches. My name is Brian York. I'm with Growing Green and Rebel Strategies out of Arizona. Been involved in the legal cannabis space for the last 9 years. Touched pretty much every aspect with specializing in cultivation facility design, construction, operations, in both indoor and greenhouse environments. My background prior to that was parts manufacturing and supply chain logistics, where I hold a degree, and I'm looking forward to sharing my thoughts with you guys.
Thanks, Brian. To my right is Randy Lenz with Anden. Randy's kind of representing the manufacturing angle or equipment angle as far as, on this panel and in this process.
Yeah, thank you. Randy Lenz. Hello? Here we go. Yep. Randy Lenz with Anden. Anden is an indoor air quality company for the cannabis space with humidification and dehumidification solutions. I've been with the parent company for 9 years.
I think your mic might be losing juice.
I've been with our parent company for 19 years, and the whole time I've been humidification and dehumidification solutions for residential, commercial, and now cannabis space has been what I do. So I work tightly with growers, cultivators to make sure that we bring the right products to market, and love to talk to everybody and get things dialed in so we have our latent and sensible solutions covered.
Thank you, Randy. And then last but not least is Haley Moore, representing the consulting engineer or engineering design angle in our, in the topics we're going to talk about.
Yeah, my name is Haley Moore, as Troy just said. I am a mechanical engineer. I've been working at Surna for over 6 years now, designing indoor grows, specializing in mechanical design, consulting for clients, construction administration, and project management. So,
thank you, Haley. So, first slide here as we get going is showing just some of the, you could call them HVAC approaches or topics to talk about. Here at Surna, we've designed all of these different systems and all different combinations, as we'll discuss. So, we feel like really there's not a one-size-fits-all approach that's going to work. Some of these things are appropriate in some applications and not in others. Some are a better fit and some aren't. So really what we're going to talk about here is kind of these four different topics, and then kind of go into a thought process experiment sort of at the end. Obviously 30, 35 minutes, then some Q&A. We're not going to get too deep into the process. But just to kick us off here, Haley, I was wondering if you could kind of talk about, just give us a brief overview of these four different topics, and then we'll go through each one by one and kind of dig deeper into applications and implications of what they do.
yeah, so the first bullet point of standalone heating and cooling and dehumidification versus an integrated approach. The biggest difference is having the air mixing within the unit versus having separate units within the space. So with the integrated approach, you can have less overall units, so it's a little less maintenance, and you can get a more mixed air temperature off of the unit into the grow space, but it can be bigger controls, cost, and other components that we'll get into later. Yeah, so that's...
So is it safe to say with standalone cooling and heating and dehumidification, we have separate units dedicated to each versus integrated, maybe all those things are in one unit together?
Yes, that's exactly right, Troy. Yeah, and then DX versus chilled water. You've got separate units outside for chilled water. Piping is going to be a big component to consider as far as where you're going to route the piping and have the equipment versus DX, which is just ducted into the facility, similar with a split versus package. You have a refrigerant piping connecting the split system versus having the unit packaged outside and ducted in. So it's just different components to consider what the facility infrastructure can handle and the cost points of having a ducted versus ductless system.
Yeah, and then last but not least, kind of ducted versus ductless. I think that's pretty self-explanatory, right? I mean, it's there's equipment in the space, non-ducted. There's some, there's some advantages to that, and then there's ductless systems or ducted systems that have advantages as well. So it's a give and take, as most things in life. Brian, I was wondering as we dig deeper here and look at some of the bullet points, if you could kind of talk to us from the owner-operator angle, advantages and disadvantages you see on standalone systems versus integrated, which was the first bullet Haley just hit on.
Yeah, to touch upon some of the points Haley mentioned, standalone is exactly that. You have dedicated equipment for cooling your space, dedicated equipment for dehumidifying your space, whereas an integrated system is going to incorporate both of those aspects into one packaged unit. Some advantages I see with standalone is you're going to have simplistic controls. It's a little bit easier for most standard contractors to do the installation, and the engineering may not be quite as robust as when you start talking with an integrated system. Oftentimes you'll find your controls to be far more complex as you're asking a piece of equipment to, hey, be an air conditioner right now. Okay, quickly pivot and pull water out of the air and be a dehumidifier. Past that, you'll start to see some efficiency, capacity increases, if you will, when you get into the integrations. You're utilizing the equipment a little more efficient in that you don't have to have as much infrastructure, if that makes sense.
Sure, less units, more complex unit controls maybe would be a good way to describe that. So with the integrated system, we're going to have complicated controls just due to all the different aspects the unit has to control. Haley, hoping maybe you can hit on why a designer might choose one of these approaches versus the other, good or bad. Why would you what would be a time where you would want to do a standalone system, and what would be a time where you'd want to do an integrated system?
Yeah, so this is one of the first conversations that we have when we start a project, is just looking at which kind of system is going to be the best fit for the facility. As far as space constraints with an integrated versus standalone system, the integrated system is going to require more robust infrastructure if you're going to put units on the roof or outside. We just need to have that space, so that can be an automatic issue with some facilities, and then the cost component as well. So those are the two biggest things. I mean, standalone systems can be great, just having 2-pipe chilled water with dehumidification, but you're going to get more efficiency from an integrated system. The units are going to run more consistently, and so that gives them some longevity as well as efficiency there.
So less cycling with an integrated system than
Yeah.
you might see with a standalone system.
Yeah, and the standalone system has the benefit of having more units typically in the room, so you've got more redundancy. It's a little bit more maintenance, but there is that trade-off that a lot of people find attractive.
Sure, trade-offs as in anything. And then finally, Randy, obviously you guys make dehus, as everyone knows, at Anden. I guess the initial assumption would be that you'd probably only have standalone dehus in a standalone or a decoupled system. Certainly you might have more, but is that necessarily the case, even in facilities that utilize the integrated system approach?
Yeah, we see people using dehumidifiers in all types of HVAC systems that they've chosen to go with, whether it's integrated or not. And again, like we were talking about redundancy, having enough equipment in there so if something happens, cultivators are always seem to be changing what we're doing on a daily basis, new strains, new plants, going from a single, build everything out as a single tier and go to a double tier, and having flexibility and having some independent systems really gives you that flexibility. But a lot of systems, even integrated systems, sometimes have a little bit of trouble at nighttime, when there's not enough heat to reject if you're doing like a hot gas bypass, and they need a little bit of dehumidification help to get that latent load out of the space. So that's really where we come into play, is helping that, and then dry cure rooms, veg rooms, all that. We have solutions for all that. Even adding in humidity, because it's not always about dehumidification. Sometimes we need to put a little bit back in, and yeah, that's what we do.
No, I think that's a good point, and a subtlety that maybe we can't get into on the panel, but maybe if anyone's interested, we can talk about afterwards. Or sometimes you have to oversize with an integrated system. We found you have to oversize the tonnage in order to handle some of the lights off evapotranspiration, and you can actually utilize both these strategies together to quote unquote right size your equipment. So you might be able to downsize your integrated machine, which is usually a more expensive machine, supplement with some standalone dehumidifiers, and therefore kind of get the best of both worlds, so to speak. So you're not overpaying, but you are hitting that relative humidity set point, and you're getting that latent capability that you're looking for out of your room to keep your cultivars exactly where you want them as far as VPD, temperature and humidity.
And that's a good thing that you guys do. It's good working with you guys, because you're looking at all these different systems. You're not, I sell this one system and it works for everything, like you said in the beginning, because it doesn't. And having that ability to adjust and put the right piece of equipment in for the job, because we see many times we're called up later when somebody put in a system that was guaranteed to do it all and it doesn't. And you spend a lot of money, and it's a bitter pill to swallow when you have to add equipment back in. And
Sure.
So you guys do it right.
Well, we appreciate that. So kind of moving on, I think the next topic we'll hit on here is a topic. There's a lot of vernacular in the HVAC world. The word HVAC is an acronym, right? So we got a lot of, a lot of lingo that maybe someone who's just looking to build a cultivation facility might not be familiar with. So, case in point, DX versus chilled water. As Haley mentioned before, DX, in the way we think of it, means a refrigerant to air based system. So no water loop in the building. We're taking the air from your conditioned space. We're taking it to a unit, packaged unit usually outside. We're conditioning, cooling, heating, or dehumidifying that air. And then we're putting it directly back in the space. So it's a refrigerant to air heat exchange. And then chilled water is really, we've got, water can hold many more BTUs per unit area than air. It's more dense than air. It's just a better thermal conductor. Chilled water systems really utilize an intermediate chilled water loop where we're cooling that loop to the right temperature in order to hit a dew point to dehumidify the air, and then pumping that water throughout the building. So when we talk here, and I'm going to kick it over to Brian about his perspective as far as advantages and disadvantages of them both, but just keep in mind the best way to think of it if you're new is chilled water. We have this intermediary water loop that we're cooling. You're always using a compressor. You're always in mechanical cooling. You're always going to be cooling down something. In this case, we have a water loop that we're pumping into a building, so we got a centralized system, a centralized chiller banking system in a chilled water loop, versus DX, where you might have more of a dedicated unit per room, and you're pulling air back to the space. So with that little primer, I guess I'd kick it over to Brian to kind of talk to us from the owner angle about, I think you've seen them both, right?
Correct, yeah. I've seen both systems installed in various size facilities. I think you gave an excellent background on the difference between DX and chilled water. And there is advantages and disadvantages to both. Some advantages with your basic DX systems or refrigerant to air is everyone's very familiar with these. This is what's on almost every residential home, small business you can find. Almost any contractor can install these systems. Very simple to control, and generally don't require a lot of engineering. As you start to scale those systems, you start to see the disadvantages of it, whether that be your facility layout, roof loads, wall penetrations for ductwork, if it's ducted or split package, and then your ability to maintain a set point, I think, struggles in the refrigerant to air structure. You're going to have compressors cycling within the space, and you kind of have a little bit higher load deadband, if you will. I can't keep as tight of a critical environment. And in cultivation, it's extremely important to me. Enter chilled water. Massive advantage here. I have that intermediary loop that Troy was discussing that's always at that perfect temperature. The chiller bank is loaded at all times, keeping that water cold. All I have to do is throw the switch on, whether that's an air handler or a fan coil, opens solenoids, conditions the space air, and boom, I can keep very, very tight control on temperature and humidity depending on the dehumidification application. Scalability with the chiller is huge. Large facilities employ chiller technology. Go to any hospital, Costco, you're going to find chilled water piping. It's a lot easier to install long-term in large spaces. Haley might have some really good additives to that from the engineering perspective, but from the cultivation perspective.
Yeah, I'll add from my perspective, there are some nice advantages to DX systems, especially simplified DX systems. Cost, they can be much cheaper. Familiarity, you got a lot of technicians out there that know how to work on a packaged rooftop or standard comfort cooling DX stuff, just because they're so common, so, and redundancy. But Haley, I guess, thinking of it from an engineering perspective, when you're laying these things out, what are you discussing with clients, and what are your thoughts?
Yeah, so the DX system, it does have a lot of advantages, like you were saying, about the install, the maintenance. They're a lot more common. It's a little bit easier to get up and running to start, but the chilled water system has a lot of benefits to it as well, as far as having redundancy outside, and then if the operators do want to, or ownership wants to operate on a flip schedule, and in that situation, since you have one main chiller plant, one main infrastructure for piping, you can reduce all of that as you flip the rooms to vary the load, and then you can keep everything more loaded up and less cycling. So it really depends a lot on the size of the facility, whether they are wanting to go to a chilled water system, I think.
And sorry to interrupt. I don't think we want to just gloss over, that's a great point, when you're talking about the flip or load sharing. When you have a chilled water system where we are decoupled from the room directly and you are flipping rooms, you might be able to get away with less overall installed tonnage, just due to the diversity of the load, sharing the load, having the machine run. I got 50 tons in 2 rooms here and 50 tons in 2 rooms here. If I've got a dedicated machine per room, I'm buying 100 tons of machine before I even consider redundancy. You might be able, if you're on an extremely tight budget, to get away with 50 tons of chiller. Again, you wouldn't have any redundancy, but pipe it over, or it'd be more than 50 because you got some nights off dehumidification load. But 70 tons or so that you can share back and forth, so you've got less overall installed tonnage. Or you could look at putting in a standalone dehu to handle that nights off, and that's kind of where I was going to ask you, Randy. I think people would think, again, it's similar to the last question I asked you, that there might not be an application for standalone dehumidifiers in chilled water systems, but I guess I'm just asking, in your experience, all the facilities you've been in, is that the case?
No, it's not always the case. There's still times when we do see that. I think, and again, it's all how it's engineered, and maybe how you're growing, maybe the outdoor climate that affects it, anything, but there are times when you get away with it if it's dialed in perfect, and sometimes you have to add in the dehumidification as well. And I think a lot of times the DX systems, sometimes get a bad rap because you might have a company that doesn't really know what they're doing to putting them in, and you've got this tremendous load during the daytime when the lights are on, so they work very well, and then at nighttime, you're grossly oversized. You're grossly oversized, and if you had just throw out a number, a 30-ton system that's running great during the day, it's so grossly oversized at night, you have a hard time with those temperature swings controlling that room. Whereas if you were breaking that up into like 3 10-ton units and having those be staged piece of equipment, so you bring on one unit at its lowest stage, you don't get all those spikes. You can control it a little bit better. But I think that sometimes they get a bad rap because of that, because somebody doesn't know what they're doing when they put them in.
I think that's a great point. People often think it's the light load or the sensible load that sizes these things. It's always the latent load, and especially how cold and dry you want to get at the end of a grow cycle. So drastically oversizing a system to handle that last week of flower when you want to pull out terpenes and pull out the purples and the nice, everything that a grower could want, might result in so much oversizing that even though the machine can meet, maybe you're vegging in place, maybe it's early flower. Even though the machine can meet those loads, it's cycling excessively. And whether it's chilled water or DX, the fact of the matter is what makes units wear out, what makes them go a long time or need to be replaced within 5 to 7 years, cycling, compressor cycling. There's lots of different strategies we can get into and talk about how you do that, but compressor cycling is the quickest way to make your machine go away, not last as long as it could. Next topic I wanted to touch on is just really, another vocabulary lesson, I guess, for those of us that are HVAC dorks, but split versus packaged. And Haley, I was wondering if you could kind of explain the difference between split versus a packaged system and what we mean when we say that.
Yeah, so for a split system, you've got outdoor and indoor units connected by refrigerant piping. So you need to have a licensed installer. It's a little more complexity for the install, but you're able to have more redundancy because you've got outdoor and indoor units. They can be modular and standalone dehumidification. The maintenance can be a little more intense for a split system versus a packaged, but the packaged system, alternately, it's all outside. A lot of times people just have a preference about not having equipment in the room, so those can just be ducted in with a single airstream, or even add some standalone dehumidification to reduce that ductwork sizing a little bit. So yeah, there's pros and cons to both approach,
But safe to say, split means it's a split package unit, essentially. The name is what is implied,
yeah,
right?
split versus package, yep.
I think the big thing there to consider also is you got refrigerant piping when you have a split system. It could be a mini split, fairly common, fairly easy. It could be a complex split system with hot gas reheat, hot gas bypass. At that point, really the operation and how long your unit's going to last, mainly oil return getting back to the compressor, is going to be largely determined by how good your contractor is at following instructions and piping up refrigerant piping. There's a lot of great ones out there. There's some that aren't so good. If you have a split system and you're constantly losing compressors, not lasting more than a year, something to consider, even if you're an existing owner-operator and losing them, is look at that refrigerant piping if you do have a split system. Finally, Brian, I was hoping you could talk us through ducted versus ductless systems, and then I thought we would kind of wrap everything up here with a slide kind of going through a decision process, as if you were the owner-operator.
Yeah, so very self-explanatory, ducted versus ductless. Just as it sounds, a ducted system is going to utilize generally large metal ductwork to move the conditioned air and the return air from the space. A couple of challenges with this when you start getting into large-scale cultivation facilities is where are you going to put this ductwork? We have really large systems going into these spaces, and the site itself can play such a factor in where you can place them and how you can get that ductwork through, whether it's roof penetrations, wall penetrations. You're not talking about small little holes like a split system would require for refrigerant piping. You're talking upwards of 5 by 5 holes through tilt walls, or 10 by 10 holes through tilt walls, and then large ductwork. With that ductwork and the length of it becomes the issue of now you're cycling all your grow environment through there. Are you going to start having issues with molds, mildews, odor escaping if it's penetrating outside, and now you're in an odor environment and your municipality might have an issue with that. When we talk ductless installs, whether that be split system or chilled water, those penetrations become a lot smaller. You may only have to do a 12-inch pipe penetration for supply and return, and you could run 500 tons worth of cooling through your facility. Now with that, the disadvantage comes, you have to start hanging more equipment within the grow space, whether that be air handlers or fan coils, circulation fans, whereas that ducted system kind of is inclusive of that.
Good point. Going back to the earlier topic, air is less efficient as a thermal conductor than refrigerant or water, so we need bigger ducts to move that air through in order to get all the BTUs in and out of the room that we need. Haley, Randy, anything to add to Brian's thoughts, or do you think he kind of covered it from your point of view, the benefits of ducted versus ductless, or vice versa?
Yeah, I think he covered it really well. The biggest complication of the ducted system is the exterior penetrations for the ductwork and the possibility of having contaminants coming in. That risk is there. But there's also benefits of you can have like a purge system running right through the unit, so it's less equipment that you have to put there, where we always recommend having some type of a purge ventilation system, even with a ductless system. So that would be a completely separate system, so it's a little added cost there. But yeah, that's pretty much.
Go ahead.
And just when it comes to dehumidifiers alone, they can be ducted in or in the room, and we don't see too many of them that are ducted outside of the room, but I prefer that. It's nice to be able to get to the equipment when you need to. If you have to do any maintenance or service on a unit in the middle of a growth cycle, it's nice to crawl up on the roof deck, pull the panel off, and replace a fuse if you have to, then get a ladder or scaffolding and go over top of the plants.
Right. Good point.
That's a great point, Randy. I think a lot of people overlook that a lot of cultivators will maximize their floor space for canopy within these rooms, shove a ton of equipment overhead, and if you have a problem, God forbid, mid-cycle, how do you access the equipment and how can you service it? It's a huge trade-off. We talked about the possible contaminants within ductwork and things like that, but it really comes down to, the site application of, do you want to run the risk of not being able to access your equipment mid-cycle, or it's very, very challenging, try to move plants, say you're, week 5, 6, heavy trellis, tightly spaced plants. I've been there, climbing up on ladders between canopy is very challenging, so something to think about.
No, it's a great point, Brian. Really, like anything in life, there's trade-offs, right? So the fact that it's outside the room, we can access and work on the equipment in a ducted system, but ductwork can be hard to clean. No ductwork is leak-proof, so if you're in an odor-sensitive area, a lot of times folks aren't, but if you are, where either by the municipality or just neighbors, you need to really consider odor. There's no leak-free ducted system. Anyone will tell you there's an accepted amount of leakage in ductwork, encasing of equipment, so odor goes along with it, and bio concerns go along with it, biological concerns. If you're under any sort of negative pressure anywhere in that ductwork, you're sucking stuff in that's in the outside environment. You're not blowing it out. So, all right, with that, I think we want to move on to kind of how to choose a system type, right? This is kind of just a quick example of the things that an engineer, an owner might consider when working together on designing one of these systems. Again, we're not advocating for one clear answer or one type of system, and there's no silver bullet here. You got to work through some of these things, and what's right for you might not be right for your next facility when you expand into another state. So with that, I guess I'll kick it over to Haley, because you've done, I don't know, how many designs have you done at this point, Haley, do you think?
Probably close to 100.
Yeah, you've been involved in some way or been in your career. Haley's been with Surna longer than I have. So with that, maybe from your point of view, maybe discuss how you would talk through these things with an owner, and maybe Brian, you jump in and talk about, from the owner's point of view, how you might counter or what questions you would ask Haley concerning some of these things.
Yeah, so the main components that we look at when we're first getting a project started, as we've discussed throughout this panel, is the cost implications of the different options, and the space constraints on the facility is a big one, because that can rule things out right away. Also, the geographical location of the facility, and the cost of energy, whether gas might be not an option or an expensive option, or electric, like in California, is not an option at all. So looking at 4-pipe or VRF is better there. So those are the big components. And then...
So when you say space, sorry to interrupt, Haley, you mean, say an owner's very concerned about CapEx, they want to get up and running, they're looking at something that's a packaged unit, because it's got a nice lead time, it's got a nice price point, we can size it to hit the temperature and humidity targets they want, but talk about how they might not be able to utilize that type of equipment for structural concerns or space constraints as it relates to the site plan and that sort of thing.
Yeah, so those units, you need at least one per room, and they're fairly large, so they either need to go on the roof or they need to go around the exterior of the facility, and a lot of these facilities are on a street or have a parking lot there, and their roof is old, or they just don't want to pay for that structural component of having equipment on the roof. It can get very expensive, very fast.
It's a structural upgrade to reinforce the structure in an older building.
Yep, so those are some things that we can put together pretty quickly to see if it's a feasible option.
I think in addition to that, Troy, you often find that different municipalities will have screening requirements for roof or sidewalk view that can play a huge factor, whether you're going to do a packaged unit or a chilled water piping system.
Yeah, so in that case, if I've got some of these site restrictions that won't let me put it on the side, and I don't want to pay for a structural upgrade, even though I'm concerned about CapEx, overall impact to my project is a packaged DX system at that point my lowest CapEx?
Generally speaking, yes, but I think you have to start asking yourself all the questions we've covered in these slides, which is, first, do you understand your options available? Then start looking at your site restrictions, which Haley touched upon, what's your structure look like? Do you have roof load capability? Then look at your business plan as an operator or as somebody getting ready to build a cultivation. What is your canopy size going to look like? Room layouts. Do you have water usages in front of you? Power infrastructure availability is a huge factor.
Big factor, yeah.
Haley brought up gas. That opens up a whole other world. Past that, geographic location, and your timeline. Supply chain and timeline can be one of the biggest deciding factors. I've built facilities out where the intention was a chilled water system, but they had to be operational in 120 days. And a couple hundred tons of chilled water is not something that can be engineered and produced generally in that timeline.
Yeah, I'll tell you right now, due to supply chain issues, we're looking at half a year to get a chiller. So if you can't plan ahead and you're not ahead, or for whatever circumstances don't allow you to wait that long, we're done with chilled water discussion. We're back to DX or some form of packaged DX. So, Haley, I was wondering if you could maybe touch on how, lower temperature and humidity targets at the end of flower, I kind of talked about it earlier, how that might push you to a certain type of system or desiccant or those sort of things instead of vastly oversizing systems.
Yeah, so the limitations of chilled water or VRF system, there are temperature and humidity set points that are at the low point of what you can reach using either of those systems, just due to the dew point on the coil. And so the limitation is right around like 75 degrees, 50% humidity. So if there are needs to go to lower temperatures, we can, for instance, in a dry room, dehumidifiers can go down to 60, 65 degrees, and then we can supplement with chilled water. So that's feasible in a dry room situation, but not so much in a grow room where we might want to look at like a desiccant unit to supplement.
Yeah, at some point it's diminishing returns. You need so much more equipment to just get an incrementally lower RH that there's different technologies that start to make sense, even other than this DX and chilled water question we've talked about.
And probably something to think about too with that, Troy, is people need to understand the advertised rates of some of this equipment. When Haley's talking about, dropping a dry room down to 65 degrees, most dehumidification equipment is specified at an 80-degree room is where you're going to get, your max water removal. You start talking about 65-degree rooms, you're significantly reducing the efficiency of that dehumidifier, and having engineers who can walk an owner-operator through this so they understand it and ultimately have a successful installation and then operation is key when you're building out a facility like this. Going backwards and spending good money after bad is, as everyone in this room probably knows, detrimental to your business.
Sure, great point, Brian. And then finally talking about location here, certainly some technologies can better utilize economizing or free cooling, if that's a word anyone's familiar with, than others. So, Haley, I was wondering if you could just briefly, as we're getting close to the end of our time here, talk about where and when economizing might make sense and what type of systems it goes better with.
Yeah, so for example, for a 2-pipe system or a 4-pipe system where you've got your chiller outside and it gets below the temperature of the coil, it's feasible to do.
Yeah, it might make sense to describe what economizing is first.
Yeah.
Go ahead. It's free cooling without using a compressor.
Yeah, free cooling without using the compressor, so you can either get an integrated chiller with a free cooling option, or you can have a separate unit entirely. It's just fans, where you divert the water through the fans when it's below the temperature of the coil itself, and then it may need to supplement. So it makes sense if it to look at the trade-off. Below freezing quite a bit of the winter time is a good option to look at.
Yeah,
the free cooling.
Certainly the hours you can run economizing in Canada are going to be different than Missouri, which Missouri still has some cold weather, but it starts to get kind of borderline there. And if you're in South Florida, you probably, economizing isn't even in your vernacular if you're a grower. So,
but if it is an option in that location, then it's a great option. it definitely, well, and the chillers don't necessarily can't run below certain temperatures, so it frees up that option.
Yeah. With that, certainly not a complete view of what would go on here. We've kind of, tried to just kind of hit on the process and to get people an idea of how we think about projects and how we work with the owners, in our experience, that we've done over 200 of these at this point, and, just kind of the systems we have in place and how we think about how to choose a system. So that being said, I'd like to open it up to some Q&A. I understand that we are running, the presentation says I got about a minute here, so that's not a lot of time for Q&A, but we are going to be in booth 908 if anyone wants to come talk to us after the show. And Randy, where's Anden at? If anyone
Yeah,
wants
we're
to...
in booth 712, so we'd love to continue these conversations. Come on over and see us.
And Brian, you'll be at the bar, is that true, with an open tab? Is that what I heard?
Sounds about right.
I don't think Brian has a booth, but... Any questions? Anybody? Yes, sir.
Yeah, hey guys. Great panel here. Kind of just two questions. First up is, what's your theory on like sensor redundancy, sensor selection to make sure that you are getting good data to control your HVAC systems? And then the second one would be, as far as like integrations, the plant life cycle for making different set points throughout the plant life cycle.
Well, I'll let Brian address that. I'm a mechanical engineer. I'm not a grower, so I'll let Brian address the first one, or the second question you asked.
Yeah, so when you're talking about sensor redundancy, I'm a huge proponent of more data, the better. So I've used multiple sensors running to global set points on both DX and chilled systems. Utilized from simple controls, seen thermostats all the way to whether it be Priva, GrowLink, something like that that's going to integrate a much more complex system that you can access anywhere. But I think definitely you can do that on standalone or integrated, so you can run any control system regardless of the application. And the second part of your question again, I apologize?
Just like following the plant life cycle with changing set points.
Oh, yeah. So, again, going back to multiple sensors, I like advanced controls. I like to, I don't want to say tinker too hard with it, but definitely changing some set points throughout that grow cycle, particularly when it comes to dehumidification. Some people like the sunrise, sunset within a grow space. I'm big on a dry down cycle prior to lights going out. I think if you were to look at data, you're going to always see your giant humidity spikes right when the lights go out, huge heat load, turn that load off, RH is going to go through the roof. But with advanced control systems, you can do a dry down cycle prior to the lights going out and try to start cranking that humidity down so when those lights go off, you don't get that giant spike. You just go into the night cycle cruising at a proper RH. So big proponent of advanced controls there.
That answer your question? Great.
Yeah, even with dehumidifiers, kicking them on ahead of time before lights go on, just getting ahead of the curve so you're ready and rolling.
Exactly, and generally speaking, your off-the-shelf humidistats, things like that, aren't going to be able to do that. Same thing with thermostats. You want a lights-on set point, a lights-off set point, likely a dry down. So definitely look into a little bit more advanced control systems. Whether that be custom-built controls, like I said, Priva. Yeah, everybody makes an advanced system that you can look into.
So I'm sorry, unfortunately, we have to wrap up. But booth 9. You said
908.
908.
I would encourage everyone. We do have a white paper that goes into more depth if you really want to go to sleep at night, probably for most of you, but goes more into depth of these different systems and comparing and contrasting them technically. So, and you can find that on Surna.com, I believe, right?
Yeah.
Oh, you can scan the QR code right there.
I was going to thank everybody for coming out, and if you do have follow-up questions, feel free to track any one of us down. We're relatively approachable, like Troy said. So,
yeah.
I
I was just going to say thank you so much. Yeah. Well.